already discussed 9 examples of permutation. What is permutations? The order arrangement of objects called as permutation. Today I will discuss some different type of permutation. First I will discuss circular permutation. When we are arranging objects around a circle, it's called as circular permutation. Let this is a circle and we are arranging objects around the circle. It's a circular permutation. Number of permutations of n objects around a circle equals to n minus 1 factorial. Generally, it should be n factorial in normal cases, but in case of circle, it's n minus 1 factorial. Let's see one example. How many way 5 boys and 5 girls can sit around a circle table so that no 2 boys can sit side by side? Similar type of example we already did. It's example 9, but it was in a row. How many ways 5 boys, 5 girls can sit in a row so that no 2 boys are sitting side by side? Here it's a circle. In case of row, girls can sit in 5 factorial way, but here girls can sit in n minus 1 factorial, means 4 factorial way. So first we'll set the girls. So girls can sit in 4 factorial way. That this is girl. These 5 girls can sit in 4 factorial way. Then how many spaces are there? 1, 2, 3, 4, 5. There are 5 space in between girl. So there boys will be sit. So they can sit in 5 factorial way. There are 5 places. In that 5 places, 5 boys can sit in 5 factorial way. So total way will be 4 factorial. Multiplication of 5 factorial, it's 2880. But in case of row, girls can sit in 5 factorial way, and in between girls there are 6 places where boys can sit. So permutation of 6, 5 that boys can sit. In total multiplication is 86400 way. So when you are arranging objects around a circle, it's a circular permutation. In normal permutation, it's n factorial, whereas in circular permutation, it's n minus 1 factorial. Next, permutation with repetition. In previous all example, we saw permutation without repetition. If one person is sitting one place, means that person cannot sit in other place, right? Now permutation with repetition. So number of permutation of n distinct objects taken k at a time with unlimited repetition equals to n power k. Let's see one example. Example 11. How many way 5 letter permutation are possible with letter A, B, C, D? We have 4 letter, and how many way we can do 5 letter permutation? It's simple. 4 power 5. 4 power 5 is 1024. If repetitions are allowed of n distinct object taken k at a time with unlimited repetition, the number of permutation equals to n power k. Suppose we have n objects of which n1 objects are alike, n2 objects are alike, nk objects are alike. Means there are total n object, n1 are similar, n2 are similar, nk are similar. Then number of permutation of n object taken one at a time equals to n factorial divided n1 factorial multiplication n2 factorial till nk factorial. Let's see one example, you will understand. Example 12. How many 10 letters permutation are possible with the letter of the set AA, BBB, CC if all letters of this set are used at a time? So how many times A are there? 2A, 3B, 4C. In total 10 letters, so it will be 10 factorial divided 2 factorial multiplication 3 factorial multiplication 4 factorial. So 10 factorial, we can write 10 multiplied 9 multiplied 8 multiplied 7 multiplied 6 multiplied 5 multiplied 4 factorial divided by 2 multiplied 3 multiplied 2 multiplied 4 factorial. So this 4 factorial will be cancelled. Then 2, 3, 6 will be cancelled. This 2 can be cancelled with 8. So it's 4. So after simplification, we'll get 12600. 12,600. Next example, example 13. How many binary sequence of length 10 are possible with 6 ones and 4 0? So in that 10 length, there are 6 1 and 4 0. So it will be 10 factorial divided 6 factorial multiplication 4 factorial. It's 210. 10 multiplied 9 multiplied 8 multiplied 7 multiplied 6 factorial divided 6 factorial multiplied 4, 3, 2, 1. So this 6 factorial will be cancelled, 4 to 8 will be cancelled, 3 9, so 3 will be here. So 10 multiplied 7, 70, 70 multiplied 3, it's 210. Now another example, example 14, a coin is tossed 10 times, number of outcome with 5 heads and 5 tails are. So total we are tossing 10 times, so number of possibility that 5 heads and 5 tails come. So 10 factorial divided 5 factorial multiplied 5 factorial. It will be 252. 10 multiplication 9 multiplication 8 multiplication 7 multiplication 6 multiplication 5 factorial divided 5 4 3 2 multiplied 5 factorial. This 5 factorial cancel, then 3 to 6 cancel, 4 here 2, 5 here 2. 2 multiplied 9 multiplied 2 multiplied 7. So it's 252. In today's lecture, I discussed different type of permutation like circular permutation, permutation with repetition and similar type of permutations. In next lecture, I will discuss combinations. If this lecture is helpful for you, please like, share and subscribe. Thank you.